morning. My name is Nicholas Cobb. I am the conference manager here at the East Mediterranean Gas Congress, and otherwise known as EMC. But for today, I'll be chairing the last of our pre-summer webinar series, which today will be looking and assessing the current digitalization of the oil and gas industry, not only in the Eastern Mediterranean, but more broadly as well. So today we'll be covering topics such as cybersecurity, the role of digital technologies and integration, digital integration strategies into subsurface operations, offshore, E&P activities, data rooms. We'll cover a whole section of points today. And if we don't cover any particular topics that you're expecting, please do write in, and we can always endeavour to ask our experts and come back to you. So without much further ado, it's a great pleasure to introduce our two speakers. We have Walid Haggag, who is the Technical Support Assistant Manager and Information Security Lead at GASCO over in Egypt. And from the UK, we have Steve Hall, who's the chair of the Society for Underwater Technologies International Committee. So as I say, welcome, a very warm welcome to you all here today. And I would like to kick off the proceedings by asking Walid to start with today's sessions. Thank you very much indeed. Walid, over to you.
Hi, how are you? I'm really very happy to join this webinar. My name is Walid Haggag. I'm working as information security engineer and technical support in GASCO company in Egypt. Today, I will gonna talk about a most recent topic that's happening every day in all companies, which is awareness leakage. I will start my presentation with a small video. By the way, my nickname over the internet is Hackers Hunter because I'm always using social engineering tricks to test the employees in my company. So my slogan is hacking minds before hacking computers. Today, we're going to talk about the impact of information security in the organization. First, we need to know about the malware or malicious software, which is any piece of software that was written with the intent of doing harm to data or device or people or whatever. There's a lot of types like malware and viruses, trojans, spyware, ransomware, a lot of types that can infect any computer and cause a damage to the digital assets. Malware statistics for 2021, starting with something terrifying, which is all types of malware, especially ransomware, cyber attacks are evolving nowadays. In 2019, 93.6% of the malware observed was polymorphic. And over the last year, malware has increased by 165%, which is 7 out of every 10 malware payloads were ransomware. 38% of cyber attacks consist of email-based phishing scams on employees. Ransomware and social engineering are the top of the cyber threats all over the oil and gas sector and all over the infrastructure companies. 39 of the global data breaches caused by malware were ransom. 64 of all major incidents targeting industrial control systems, ICS, are 64 of the major incidents. 65 of the ransomware attacks were delivered via email. 63 of network intrusions are the result of compromised credentials. All these terrifying numbers. And finally, US ransomware attacks cost an estimate 915 million in 2020. February 2020, a ransomware attack cost Denmark-based company about 50 million. Almost 200 million ransomware attacks occurred in the first 9 months of 2020. The average downtime due to ransomware attack were 20 days in the fourth quarter of 2020 compared to 19 days in Q3 of 2020. So 38% of malicious email attachments were from Microsoft Office format. 34 of business hit malware took a week or more to regain access to their data. Let's talk about ransomware much more deeper, facts and trends for 2021. With global cybercrime damages predicted to cost up to 10.5 trillion annually by 2025, which is a huge amount of money. The cyber attacks on the oil and gas sector, there is a lot of papers over the internet talking about this topic. I just choose this paper, which is IEEE paper. It's talking about the past 2 decades on oil and gas operational and information technology system, which experienced constant digital growth, closely followed by an increasing number of cyber attacks of interconnected systems. All oil and gas sectors, or most of them, using SCADA systems, the control center, like you see on the diagram, servers of the SCADA. So using attacks through an IT and digital infrastructure, you can do some kind of man-in-the-middle attacks on the protocols and signals, so you can do a penetration for the network of the SCADA and do SCADA attacks through field devices or through direct attack on actuators like PLC and RTU and relays, like you see on the diagram. And this is a more detailed diagram to see the attacks through the IT digital infrastructure, which can cause infection and remote access to AGIs or to pipeline manufacture and pipeline things. How many organizations reported ransomware attack in the last year, which I'm talking about 2020? Saudi Arabia at the top of the list and Japan at the end of the list. Saudi Arabia, 88%. System targeted most by ransomware, the most infected system is Windows, which is 95%. And now Mac OS is 7%, Android 5%, iOS is 3%. Cybersecurity threats against the Mac on the rise. On 2018, it was 4.8, and nowadays it's 19.5. So the average number of threats detected per endpoint on a device with a Mac OS increased about 5 times. Nowadays, most of the attacks is following the domino effect. Domino effect, which is infecting one of the biggest company, and these biggest or provider company can infect all the other related or connected companies. That's why the SaaS is the most infection method they use. As you know, there is a user management services and provider managed service. User managed service that you had all things on your premises, like application, data, runtime, everything, virtualization, network storage. And on the SaaS, which is a software as a service, everything is provided from the provider. The SaaS application targeted by ransomware nowadays reached 64% on a cloud like Dropbox and about 2% on Salesforce. Colonial hack, how did cyber attackers shut down pipelines? All of us heard about the attacks happened to the United States. It's happened by dark side. Knowing that cybercrime increased about 600% due to COVID-19 pandemic. Most of the recent attacks that happened to the oil and gas sector was happened due to a human error. And through the computer they're using from their home, using remote access software like Microsoft Remote Desktop or like TeamViewer or any remote software. So global spending on cybersecurity is predicted to exceed 1 trillion by the end of 2021. Every internet user is at serious risk of identity fraud or data theft and invasion of digital privacy. The zero-day exploits nowadays are predicted to reach 1 per day by the end of 2021. Cybercrime damages are predicted to cost the world 6 trillion by the end of 2021. So we need 4 things to do: training, education, awareness, and make the message short and simple, because all our life is online. So we need a wake-up call to protect our digital assets. One of the most common websites that anyone can use for free to gather information about infrastructures or companies or whatever the organization that's connected to the internet is wiggle.net. It's having all the information about Wi-Fi network all over the world. You can gather some information from these sites and then use it for next attack by using social engineering. And this is one of the closest streets in Egypt, one of the streets in Egypt. I do a close-up. zoom in to see the Wi-Fi that is available with the names and the location. So areas of information security having 5 keys: physical and operation security, and network security, and communication security, and personal security. The personal security is the most important thing in the 5 items. Why? Because if you had a good physical security and operation security and network security and communication security, but the personal security is not good, you will be the hole to your system. The social engineering attacks is one of the most common attacks happen to the oil and gas sector nowadays, by gathering information from the websites of the company, or by using an email, phishing email, then pretexting, and then doing mind tricks, then persuasion, targeting, and reconnaissance. So using these techniques need a lot of things: education, training, and awareness. The education, training, and awareness are the only defense that we can use right now to protect our digital assets. So I did some kind of survey for the employees on our company all over the branches. We have about 25 branches all over Egypt, before training and after training, talking about terms understand about security. I asked them about spoofing, smishing, sniffing, malware, spyware, a lot of terms like you see in the graph. That's the percentage of the awareness of the people before the training. And this is after the training, it increased about double or triple, they know. So oil and gas sector security review says that security challenges and training solutions to stay protecting digital assets of the oil and gas industry, you should do a lot of things. One of these important things is OT system management. What is OT system management? It's the active administration of operating technology systems, like asset inventory, backup and restore, configuration management to the operation technology. And also doing an ICS security, industrial control system. Most of the attacks happened for the last 10 to 15 years, started with Stuxnet at Iran. It's all of them industrial control system. So it's one of the different types of control systems are used for monitoring industrial process. It can be composed of just a few hundreds or thousands of connections. For instance, remote sensors that check your machinery and then send it to the industrial control system. And in short, industrial control system give operators an easy way to manage, monitor, and control industrial processes. Fighting the trend of the malware. To increase cyber team performance in IT and OT for oil and gas sector organization can adopt continual learning opportunities for teams to grow in cyber skill and competency to stop threats before they hit a network. 87% of oil and gas companies have been affected by cyber incidents in the past 12 months, and 46 of cyber attacks on operational technology within oil and gas industry go entirely undetected. Oil and gas statistics say that 37% of cyber attacks consist on the oil and gas industry are from a virus or a worm. 38 of cyber attacks consist of email-based phishing scams on employees. Oil and gas industry must be alert to physical and cyber threats because artificial intelligence will change our world. Oil and gas cyber security review say that cyber security threat to Britain oil and gas sites attack could cause damage. PTIA cyber attack ransomware spread across Europe for many countries and shut down Spain. Hibiscus Petroleum suffer from cyber attack. Cyber rats or remote access Trojan, a computer code delivered to remote access Trojan to take over plants. Oil and gas production and service companies have been hit by cyber attacks, ending with Colonial that happened to the United States. Global oil and gas cyber threat perspective. In Black Hat 2019, they identified a new threat group capable of ICS attacks that is currently targeting oil and gas facilities to target Middle East, Central Asia, and Africa. The rise in ICS security threats against oil and gas companies has coincided with a spike in political conflicts between various nations across the globe. Finally, most target industries globally is power and utilities. Second is petroleum sector. Thanks for your time. and I'm really happy to join this webinar again. If you need any question or any contact, this is all my contact on Skype and email and mobile number and everything. Thanks.
Wonderful. Thank you, Waleed. It was thank you very much for a fascinating insight there. I think cybersecurity really is one of the bedrocks really of the world that we live in, isn't it? It's one of those. It's just you know, you go back 20, 30 years, it wasn't really a talking point, but now every terrorist group, bedroom teenager that's disgruntled with the world, and terrorist group or organized criminal group, they're all looking at ways of extorting money or information or other things. So fascinating, and thank you very much. And so I've got a couple of questions, I think just come in, just whilst it's relevant with your presentation before we move on to Steve. So one of my questions would be in terms of human factors. So you mentioned Stuxnet, especially, that obviously was a USB stick that may or may not have come from another country in the, you know, in the wider region, and was left in a car park. Somebody obviously goes and pops it into the computer, and it disrupts the entire nuclear grid, a nuclear power system over there in Iran. So how important would you say that physical security, things like physical penetration testing, risk assessment, control and command systems, you know, all the various, you know, access control, physical access control, all the various physical security items are in relation to cyber? Because obviously, if you've got somebody sitting, say, you know, in North Korea, you know, trying to launch a ransomware attack, well, that's one thing. But if you have a disgruntled employee, and it could be a disgruntled employee, they could walk out with data, they could walk out with other things. How would you mitigate that? How would you advise to mitigate those points?
First of all, the ransomware mitigation, starting with something you should do before the infection or you hit with ransomware. You should do a backup regularly, because most of the ransomware nowadays is zero-day exploits, which is not a recent thing, and it's a new thing, and you can find a decryption key to decrypt the information. Also, the time to decrypt the information, it takes too long time. This will cost you money and effort and a lot of things. So I prefer to have a full backup from your system, which is very important, and doing regularly. Also, separate the database from the normal system using a hardware firewall, using a software firewall, raising awareness of the people to avoid this infection, because as we talked before, and you mentioned also, Stuxnet was air gapped. It's not connected to the internet, and it's infected with ransomware, or the first code made of the first weapon made of code, by using social engineering on one of the engineers that is doing update to their system. So first firewall or first line of defense is the people that work on the organization. Second is the hardware and the physical security and the communication security and the other systems.
Okay, so again, we have two more questions just before we move on to Steve. One of which is where do you see the cyber threats coming to the oil and gas industry? Is it mainly from, say, private criminal entities, or is it terrorism, or is it more state to state? What can you give us some sort of insight there?
It's an organized terrorist group all over the world. It's not located in one country. It's a lot of people all over the country. It's a business, some kind of business, to get some ransom, to run their business for hacking another companies or another countries, or for hacktivists. Maybe some of these people are hacktivists, which defending some of their thoughts, maybe terrorists, maybe political, whatever. So it's an organized terrorist people working to get some ransom to make their business running much more better from this money.
Brilliant. Thank you. And final question before we move on would be, what more can be done besides raising awareness to counterattack or defend against attacks that have potential to cripple an entire business? So really, what can be done to level up against vulnerabilities, say through raising awareness? What can be done to help staff?
For raising awareness, for example, I am keeping about every week 1 or 2 training sessions for the top management people and for the operational people, telling them the recent common attacks, how they can detect and prevent, and also if they had an infection, what shall they do. Second thing is upgrading their software regularly. Also, the users should not install any third party or unlicensed software or a cracked software. Also, the website they use internally on the company, inside the company, they are filtered to prevent some kind of malicious code and some kind of downloading malwares or things like this. A lot of steps we should follow, and these steps should be regular. It can't be happen for 1 week and then the next week we stop. It should be every day. So we do this normally to all our employees. We had about 5,000 employees all over Egypt. So I am going to all the branches regularly with my team and doing awareness and training for all of them. It depends on their location on the company. The top management differ than the normal people, differ than the technical people, differ than the IT people.
Okay, thank you. So Waleed, I'm sure there'll be more questions, and I have a particular question for you later about EMP, data management. So that's one for later. But without much further ado, everyone, thank you very much, Waleed. A very interesting presentation. And now I'd like to hand the floor over to Steve Hall from the SUT. Steve, the floor is yours.
Excellent. Thanks very much, Nick. And really, really brilliant presentation, Waleed. I'll follow up on a couple of the points you brought up in my own. Let's see if this screen will share. Okay. Right, can you all see that? I hope. Yeah, let's put it onto screen view. Right, okay. I'm going to focus in my presentation on how we're going to digitize the marine renewable energy and floating offshore wind sector. You know, learning from these lessons that the hydrocarbons community has picked up through huge effort over the last, particularly the last 10 years, and with preliminary work in the period before that. A little bit about me to explain who I am. I'm chair of the Society for Underwater Technologies International Committee, which is how I know our friends in Cyprus and the Eastern Med. I'll say a little bit more about that later. I'm the former vice chair of UNESCO's Intergovernmental Oceanographic Commission, so my particular professional background is very much in marine policy and law. And just to follow up on what our friend Waleed was just telling us, this whole issue of cybersecurity is massive, absolutely massive. And one of the reasons why the international legal community, amongst others, are so interested in this is the move across our industry to autonomous systems. Many of you will be aware of the presence of marine autonomous systems as survey equipment, the kind of autonomous underwater vehicles, autonomous surface vehicles, all of these systems wandering around the global ocean, gathering data, making maps, making charts, following pipeline routes, following cable routes. And of course, these systems rely on satellite navigation. They rely on software interfaces. There isn't usually a human operator taking part in the survey. Once the machine is off doing its job, it's operating on its own. So if a malicious actor wishes to spoof the navigation system, which is very, very easy to do, by broadcasting alternative GPS signals, or by overwhelming the local GPS and replacing it with a altered digital data, you can cause a lot of problems. You can imagine if your multi-million-dollar offshore survey plan comes back and everything has been displaced by 50 meters or even 5,000 meters, or even worse, your ship sails into somebody else's territorial waters because it thought it was in international waters. You can get into all kinds of fun and games here. So what Waleed was just telling us about cybersecurity matters incredibly. This is hugely important, and the kind of thing that can even cause wars. We've seen just in recent weeks examples in the Black Sea of ship AIS tracks been altered so that it looked as if Dutch and British warships were operating within Russian waters. And very, very dangerous. When politicians start authorizing these kind of interventions, things can go bad very, very fast. On the slide, it shows the logo of Marine Energy Wales. I'm currently operating as the program director for installing floating wind and marine renewables into the Celtic Sea region, and chairing the Celtic Sea Alliance, as well as chairing SUT's International Committee. So, offshore renewables generally have been very slow to adopt the digital solutions that oil and gas have been using now for quite some time. Just a couple of years ago, 2019, the Offshore Renewable Energy Catapult Survey in the UK showed that 94% of the recipients of the survey agreed that the offshore wind industry isn't extracting the full value of data and digital technology as well as it could. And although the benefits of digitalization are well understood in the hydrocarbon sector, that probably isn't so much the case with the new entrants that are entering the sector to take part in offshore renewables. We have quite a lot of startups who haven't had the experience of working in the marine environment before. They're often entering from terrestrial energy, so land-based energy suppliers, particularly the wind operators. And so there isn't necessarily the same corporate culture or the corporate memory to understand the importance of the full spectrum of offshore operations. Even simple things like materials choices, the quality of the connectors you're using to connect your infrastructure to the grid. Learning the lessons of over half a century of oil and gas exploration and production and applying that into marine renewables is surprisingly not going as well or as fast as people might expect. And learning the benefits of digitalization likewise hasn't quite come into offshore renewables as well as you might think. We know that for wind and marine renewables, digital technology will add important capabilities. You need to be able to stabilize your supply to the grid. Fundamentally, whatever form of offshore renewable energy you're using, whether it's floating wind or whether it's marine currents or whether it's waves, it could be floating solar panels, lots of potential solutions. All of these generators have one simple job. It's to create electrons. That's all they're doing. They're creating electrons to supply to the grid. You can either supply it to the grid, or you can supply it to a electrolysis plant to make hydrogen, or you can be supplying the electrons into some form of energy storage device. These could be batteries, or this could be pumped storage, lots of potential solutions. And because of the nature of this work, and also the other big difference with all of the offshore renewable systems is there isn't usually a human on the platform. Nearly all of these systems are unoccupied. There's no human on board, apart occasionally from a maintenance crew. So the systems have to be able to operate reliably without any human intervention. Even the simple acts like somebody with a spanner or a screwdriver to adjust a component aren't available on most offshore renewable energy systems, which brings us straight back to what Walid was telling us about the importance of having good cybersecurity. Because if all of your systems don't even have a technician on board to be able to correct a fault, to correct an error, your vulnerability to hacking, and ransomware demands is potentially very, very great. Somebody could easily send a command to the offshore wind turbines to feather the blade, to stop producing electricity, all kinds of things like that. So cybersecurity, very, very important. And I already put it down as one of my final points there, is that the drawbacks do include vulnerability to disruption by malicious actors if security isn't good enough. It remains to be seen if the offshore renewable industry will be as attractive to hackers as offshore oil and gas have been. Generally, the offshore renewable companies don't have the same financial reserves or financial resources, so it's possible they won't be such attractive victims. but anybody who is pushing electrons into the grid is potentially at risk of being hacked or attacked in some way. As the world moves through energy transition and towards being reliant upon electricity for powering our cars, for our trucks, for our trains, for our ships and aircraft in the future, you can only imagine how attractive anybody who produces electrons is going to be to a cyber hacker. So a very, very important aspect. So let's change the slide. So a key benefit also of digitalization is this ability to utilize digital twin technology to improve and upgrade your operations. This has been pioneered within oil and gas sector very well for some years now. Creating digital twins of the systems that you have operating offshore to be able to test their efficiency, to test the value of upgrades, to model failures and downtime, hugely beneficial, and again has enabled companies to slightly reduce the number of staff who are working offshore as they're able to automate and upgrade these systems. Offshore renewable energy, not having human crew working on the ships, stands to benefit hugely from application of digital twin technology. I wouldn't say it's been rolled out as well as it could be at the moment. It's still very, very early days. A very good example of the benefits you'll get from a digital twin has been published by DNV in their report A204, quite easy to find online, called the Digital Twin Buyer's Guide, which sets out sort of 4 key questions that a company may need to ask if it wants to start going down the digital twin route. Definitely worth a read. It helps you understand, is this the kind of solution your company needs, and lends itself very well to offshore renewable operations. We're also finding digital twin technology starting to be used by the oceanographic and the meteorological community for the first time in years. There is a great move we've just entered from January 2020, the United Nations Decade of Ocean Science Sustainable Development. The key projects being carried out by researchers across the globe is to create a digital twin of the global ocean. It's never been done before. Very hard to model the ocean at such high resolution on such a large scale. But good advances have been made. And again, as we move into through the energy transition piece and we start taking up more wind, wave and tidal energy, the ability to be able to model the ocean in very fine resolution and apply digital twins of the ocean and the atmosphere system as well have tremendous implications, being able to improve the accuracy of forecasts. And this is going to be essential for profitable offshore renewable operations. You see, the nice thing with offshore renewables, of course, the wind doesn't always blow. The waves might not be the right height in one particular area. But if you imagine you were looking at the Eastern Mediterranean, you might install an offshore wind farm off the east coast of Cyprus. Maybe the wind doesn't blow that day, but perhaps off the west coast it is, or perhaps off Malta it is, or perhaps off the north coast of Egypt the wind is blowing well. As you start to interconnect these systems, and you have interconnectors, you have the the power lines running between a disparate wide range of offshore fields. You start being able to use your modeling and your digital twins to be able to predict when to switch your production between site 1 and site 2 and site 3, so that someone somewhere within the group, the cluster of offshore energy generating centers will be obtaining electrons. So you're getting your price from your customer, or you're supplying into your storage systems. It's huge benefits of trying to get this digital interconnectivity between systems. So we've been learning a lot of lessons on the effective implementation of commercial offshore wind, wave, tide and current technologies, certainly in UK waters. We have tidal stream energy operating now off the north coast of Scotland. We've got the first floating wind platforms going in. We've got lots of experience of fixed offshore wind, and we're now starting to deploy floating marine current turbines with lots of designs for tidal lagoons as well. One of the roles that I'm currently carrying out, we're working between Wales and Ireland on growing the Celtic Sea region as a centre for floating offshore wind and marine renewables, with the intention of that moving into hydrogen production as we get towards the end of this decade. And all of these lessons will apply to the Eastern Mediterranean as the Mediterranean region goes through energy transition as well, and becomes a key renewables and hydrogen hub. You've got so much going for you. You know, you've got unlimited solar energy, you've got a good wind resource, not a huge wave resource, but it's okay. You've certainly got marine currents. And you know, the possibilities of floating solar, you know, as well as floating wind. It's entirely likely that by the end of this decade there'll be hydrogen production underway, both blue hydrogen and green hydrogen in the Eastern Mediterranean, and there'll be a lot of lessons that all of these different regions can learn off each other. So in Wales, we launched a State of the Sector report yesterday, just again explaining to policymakers and our political masters the current state of our sector, easily downloadable online. Just look for State of the Sector report 2021 by Marine Energy Wales, and the lessons again are universal. But the final point I wanted to raise here is my old role as Chief Executive of Society for Underwater Technology. We had some wonderful discussions with our friends there in the Eastern Med, and we are in the final stages of putting together plans to launch a new Eastern Mediterranean branch of the Society for Underwater Technology out of Cyprus in the coming months, and really look forward to helping the community learn and work together for mutual benefit. And Society for Underwater Technology, we have branches in United States, in Australia, UK, we're in China, Brazil, pretty much anywhere that's producing offshore hydrocarbons. There will be an SUT branch, another major branch in the Middle East as well. So lots of lessons to learn, lots of people working for a variety of suppliers, manufacturers, supply chain, all sorts. So we'll be looking forward to working with the Eastern Mediterranean community for mutual benefit. So I shall end that there and stop my screen share.
Okay. Thank you very much, Steve. That was fascinating, very interesting indeed. And one thing I picked up there was the changing of the AIS numbers on the was it HMS Defender and the.
That's right. Yeah,
went through. I didn't realise the AIS numbers had been changed, but yeah, weird. All locations, I mean, but
yeah, that's right. They were showing them as being. There were two incidents, weren't there? There was the one where the Russian Air Force went around the ships, but about a few days before that, the Russians were showing AIS tracks showing both ships well within the territorial waters, but the dockside webcams back in where the ships were moored were showing them still both alongside the dock. So we knew they hadn't even left the port, but it was being shown all over the internet that these two ships were, running around inside Russian waters. Unless, of course, it was the dockside cameras that were being spoofed.
Well, who knows? Who knows? I mean, it could be either side there.
It could be either side, and this, of course, is the beauty of this kind of cyber disruption. It's all about sowing the seeds of doubt. It's about removing trust and confidence. So even if you don't actually cause physical damage, simply sowing doubt can affect share values.
Mirrors.
Customer confidence. It's a great tactic if you just want to mess things up.
Well, we live in a world of information overload, and what's the word? It's hard to tell what's true and what's not these days. So Steve, so everybody, thank you very much, Steve. That's a wonderful presentation. And please do put your questions into the box and we'll endeavour to answer them. However, Steve, I have a quick question for you. So at the SUT, how would you assess the the state of digitalization and technological integration, say with EMP, subsurface EMP, seabed level type of technology, the real subsurface stuff. I mean, how's that going?
It's progressing pretty well, and particularly in the some of the smaller, leaner companies, the ones that are reasonably new to the sector, and they're not perhaps weighed down by legacy systems. They're going straight in right from the start with digital. It enables them to commence production at a lower cost. It means that they can tweak the software.
Very interesting.
Other things aren't operating. So if you're not weighed down by 20 or 30 years worth of assets, which might not be able to interface directly with the new digital system, it gives you that agility to come straight in and use digital from the start. I think the other thing we're beginning to see is much more willingness between the operators to use shared systems compared with in the past, where everybody wanted their own bespoke solution down there on the seabed, which weren't necessarily compatible and didn't even use the same sort of voltages and connectors. So there's much more temptation now for people to reduce costs by going with shared solutions. Thinking though, of course, of what Walid has just been saying, the flip side of that is when everybody starts using the same solution, it only needs one company to slip up on the security side, and you can end up switching everything off for all of the users.
And actually, I have a question here for Walid and for yourself, Steve. So Walid, I'll just ask you to unmute. So in terms of E&P, but now we're talking about sort of hardcore E&P data management and identifying the opportunities and actually using that geomodeling and the data and the well reservoir data and everything else to really sort of to maximize and optimize your oil and gas assets. How do you see the technology developing there, given the East Mediterranean context? I mean, is there much technological integration there? Are we still using traditional data management methods, or what's the state of play there?
Sir, I beg your pardon. Can you repeat the last part?
Yeah. What would you say would be the state of play of sort of E&P data management, really sort of aimed at optimizing your operations? That's more precise way of putting the question.
Okay, the E&P data management to maximize our operation is normally saved on redundancy places. I mean, disaster recovery places. We put the data on 2 different or 3 different places to protect it. If a disaster happened, one of these operations to put it on a different place. Second thing that normally we do a regular backup, as I mentioned before. Third thing that the data is not located in one server and it's not located on one storage device. It's replicated in the same place to a different storage places. All the data normally having a regular check of the integrity of the data and the availability of the data to make sure that nothing bad gonna happen to this data. We are using a lot of systems like prevention software, detection software, some types of protection also to gain access. To have access to the data, it's not so simple. It's not only one password. It's having 2 or 3 factors and sometimes the biometric factors. So we are using a lot of methods to protect the digitalization assets.
Okay, Steve, what are your thoughts?
Again, I think because companies are seeking to reduce costs, I think there's a bit more sharing than used to go on in the past. I mean, obviously some data remains commercial in confidence and stays within a company, but things like, the hydrographic data, shape of the sea floor, currents, temperatures, the things that might pertain to cable laying or pipeline laying. I think there's much more willingness for companies now to share their data sets. And sometimes that's been driven by the regulators. I think there's been a tendency between the governments that are giving permission for certain blocks to be developed. It's becoming more common now for the attitude of, collect once, use many times for data sets. So they're saying that if the data isn't something that's absolutely, pertaining to your particular geological structure that you're extracting your oil and gas from. If it's anything else, that I think there is much more of an expectation the data will be shared, put in ultimately into the public domain so that it's available for other users who wish to move into the area, or for other kinds of uses. It could be there might be aquaculture operators, or as we were speaking about earlier, the marine renewables people might want to come into the same space, and those folk aren't interested in the geological conditions, but they're quite interested in what's happening in the the oceanographic and meteorological parameters.
So we have another question that's just been messaged in. What advice would you give to a new independent oil company or a new entrant into the market to develop a digital strategy for their operations, onshore operations? What sort of advice would you give?
I'll let Waleed start first.
No, you start first.
Oh.
It's a difficult question, that one, but
yeah, no, I think don't reinvent the wheel would be the first thing I'd say. There's a lot of excellent solutions already out there, and if you've got a trade body, a trade association, a learning society, professional body, anything like that, that will let you, without giving away your own commercial secrets, learn from those who've already done it, you can save yourself an awful lot of time and money. Because I think what we often see is startups come in, I think, hey, I've got this great new idea, not realizing that their rival tried exactly the same thing 5 years ago and discovered quickly it doesn't work. It costs a lot of money. So, within the realms of commercial in confidence, do be willing to go out and ask, speak to your friends, find out who's already done it and
who's doing what. Absolutely. And okay, just checking through any more questions. Okay, we have one final question here. How would you view the digital, how would you view the digital outlook for the Eastern Mediterranean as a frontier basin?
First of all, I would like to mention one important thing. The key role of the information security core is the top management, because most of the top management trying to avoid to invest for this hardware and software, which is cost a lot of money, and they prefer to invest on another things like pipeline things and the manufacture and all the other stuff. So is the main important thing, in my opinion, that the top management should know the risk that's going to happen to the organization and the business continuity that's going to affect if there is some kind of attacks happen to the organization. So this is the main point and the main thing that all of us is forcing in our organization, to convince the top management to purchase a hardware or a software, or doing some kind of training for the people to raise their awareness level.
Sure. So very much a top-down approach. Top-down approach, awareness up.
Yeah. I'd agree very much with what Waleed is saying, because we know there are malicious actors out there. Sometimes they are governments, sometimes they might be NGOs who don't want oil and gas to be developed. They could be, political rivals, criminal gangs. There's a lot of people out there who see, especially the oil and gas sector, as a cash cow. They see this thing as someone who have the resource and have the wealth to be able to pay the ransoms, or they might just not want oil and gas to be produced in the first place. And you just have to be very aware that these people are real. They're already at work, and we have to work together right from day one to get it right and have secure systems that prevent, because nobody wants big oil spills, or power outages, or gas explosions or anything like this. They cause huge environmental damage, as well as all of the the economic harm. And if we can all work together to keep this as a safe, secure industry, it benefits everybody.
See, but one final question has come in before we sort of wrap up for the day. What's the outlook, would you say, for remote operated vehicles? in oil and gas operations. That could be surface vessels, it could be underwater vessels, drone technology. How do you see that developing?
For my own part, it's huge. One of the fastest and easiest ways to save a lot of money in offshore operations is to take the humans off the platforms. And if you can do repair, maintenance, servicing using autonomous systems, as well as the routine tasks such as offshore survey, environmental monitoring, this kind of stuff, I'd be surprised if in 10 or 20 years you see that many vessels with a human crew on board doing certainly things like the survey and monitoring work. I think that will nearly all be robotic, pipeline inspections, simple maintenance. It gets complicated for hard maintenance, things like where you start needing to undo nuts and bolts and change components. Robotic technology still isn't good enough to be able to do that. But if systems are built from day one to be maintained that way, then who knows, maybe the actual offshore platforms themselves. We already see it with the offshore wind turbines. There are companies building robots that will, crawl around the blades, cleaning and repairing the blades. And we're going to see a lot more of that in offshore systems. So I think there'll still be plenty of humans employed, but they'll be operating in shoreside. They'll be in shore-based locations, looking after a whole bunch of platforms. Some of them might be remotely operated, some will be fully autonomous. And one of the positive things on that is it might attract more people into our industry as well, and a more diverse selection of people into our industry.
And actually it might also bring in younger people into the industry.
I think it will, because we know we often find companies complain they can't get young people who want to work on ships, and say, well, why won't they work on a ship? So they don't want to be out of contact with their friends, and they don't want to be, and this goes back to the cybersecurity question as well, because if everybody's there with their iPhone or their Android phone chatting away from the ship, of course, at the very least, they're giving away the position of where they're.
I agree. I agree with you totally, Steve. Also, there is one of the most important threats that causing a lot of damage to the companies is the people, as you mentioned, also by not following the rules and the policy of the company. So this can cost the company to pay some kind of money, or for the financial sector to pay to a different vendor by using some tricks like spoofing or phishing emails or spear phishing emails. So the people is the most common vulnerability in the system. So the most common secure computer is the computer that no one touches.
What about things like, just sticking with drones for a moment, what about things like, because obviously at the moment, drone technology is relatively new. I mean, it's only, 10, 15 years old, I guess, may be wrong. But the payload limit, say, for an aerial drone is quite limited. What sort of, can you see that area developing at all? I mean, say for developing, just-in-time parts for oil and gas operations, offshore search and rescue, someone goes overboard, it comes up, it drops a safety raft or something, something along those lines, or a parts or delivers, something. How do you see that, the aerial drone technology developing?
I'll let Walid go first.
You first. No.
But again, it's going to be huge, Nick. The technology is getting better and better. The breakthroughs that have been made in battery technology for the cars is all going to spin off into the drones, and I think it will be a normal piece of equipment, on any offshore platform or any ship in a few years' time, will be cargo carrying drones. That, as well as 3D printers on board the ship and on board the platform. So instead of having to carry a big stock of spare parts, they carry the blueprints, and the raw materials, and they make the part.
You click, type the number in, click enter, and an hour later you've got your part. We've seen that when Britain's Royal Navy bought the F-35 fighters, to put on the two new aircraft carriers, one of the most important parts of the purchase were the 3D printers that go with the fighters. So instead of the ship having to sail with thousands of spare parts for every conceivable thing that could break, they have, titanium powders and
ceramic powders, and they
Wow.
can make the pieces as they go. And I think that's going to be very much the future, even with quite high tech equipment.
Yeah.
The human will be there to sand the to smooth down all the corners to make it fit.
Well, I guess also you've got a whole generation of people now that have grown up, younger people especially, that have grown up with Xboxes, and they're used to simulators, and they're used to computers and smartphones and everything else. And you see it with the military as well, don't you? The embracing of say smart drone technology in the military. You see that, and a lot of the pilots are now younger.
It is, and of course the Eastern Mediterranean region, as we've seen in recent conflicts, is one of the leading parts of the world now. In terms of the development of advanced drone technology. The products that are coming out of Turkey and Israel and Egypt, lots of countries now, really sophisticated drone capabilities, initially for military purposes, but of course all of these technologies will come down to civilian users to make quite advanced capability affordable.
Wonderful. So, gentlemen, well, that concludes our questions. Do you have any final thoughts?
And I just add, this is an absolutely brilliant time for anybody who wants to get involved in offshore energy. We're just on the cusp of this incredible change, from 50 years of oil and gas to a whole new future of hydrogen and electricity, as well as oil and gas has still got quite a few decades left in them, but increasingly we're going to be moving to these new sources. And what an exciting future that is. Imagine being 25, coming into the industry now. The career these young people are going to have is going to be amazing. Yeah.
Oh, it's amazing. I mean, the technology is fascinating, isn't it? And I think we've touched on, so today, we've touched on a great number of topics, from cybersecurity to drones, to EMP data management, to, the opportunities for, I don't know, cargo drones and, subsurface operations. We've covered everything today, and fascinating conversation. And I would like to thank all of those that have attended today. And I would like to also thank Steve and Waleed for fascinating conversations. We will be releasing the video, the full video, hopefully later on today or tomorrow. And it only leaves me to say thank you very much indeed to both the speakers and to all for attending. And we look forward to seeing you at our next webinar in September, which I believe is September the 8th. But further details will be announced. Thank you very much indeed.
Thank you. Thank you. And I'm really happy to join this webinar. And I think the next event on November, I will be in Nicosia. That's something related. Yeah. I applied for this event, and I will be there by myself. It's not online.
I very much look forward to seeing you there.
I hope to see you there.
And Steve, I look forward to seeing you there as well.
Yeah.
And just on that point as well, we have a great new developing program. We have over 40 speakers, including ministers and operators and all service companies. So we have a fantastic event lining up for November, and we very much look forward to seeing you all there in November, and between November 10th as well. Thank you very much, guys.
Thank you.
Bye.
Bye.